So let's continue with the questions from the quiz number 4, from the fourth quiz. We are at question 17. How many arguments will be passed to the command echo if we call it like this? Echo, and then this. So what do you think? How many arguments are passed to this command?
6.
You think 6?
Yes.
Okay, let's see. So from here to here, there is one argument, but actually there is no space. So this one includes this one. So this is one argument. This is one argument. This is the second, the third. This is the fourth argument. And then this is not an argument because this is redirecting the output to this file. So this is a file, and this is a redirection operand. So I think it is 4 in this case. So let's check. Yeah, the correct answer is 4. And how can we check with the test example? We can do it like this. For example, for I in, and then do echo I. But let me write it like this: echo I, and then done. So this is printing this I is taking all the arguments here one by one, and they are printing. So this is the first argument, the second, the fourth, and the third, and the fourth. So there are 4 arguments actually. Okay, let's move to the next question. Which of these commands does not print foo bar? So all of these commands print foo bar, but one of them does not print foo bar. Which one does not print it?
I think it's A.
The first one or the last one?
The first one.
This one. Actually, I think it is this one, because here we have the content of the variable a, which is foo, and then it is concatenated. It is joined with this string. So this actually prints foo bar. But here we are the shell is interpreting this one as the name of the variable, and the variable a underscore bar, the variable with this name, does not exist, so it is empty. And all the in all the other cases, this is the content of variable a, and it is concatenated with this string. And here again, it is the content of variable a and concatenated with this string. Also, here is the content of variable a, and it is concatenated with this string. And let's actually check them one by one. So this is actually printing foo bar, because this is the content of variable a, and it is concatenated with this string underscore bar. Let's try the second one. Again, this is printing foo bar. And let's try the other one. Again, this is printing foo bar. And this one. Again, this is printing foo bar. And now the last one. This is printing empty, because this variable is not known, is unknown, it is undefined. So this is the correct answer. The other one, if we execute the command if read and then read var1, var2, var3, which keyboard input will set the value of var3 to 3? So we have a read command here. It is reading into 3 variables. So it is reading something and it is saving it into these 3 variables. But it is using as separator this one in this case. By default, the separator that the command read is using to split the line that we input. So we write a line and we press enter, and then read is splitting it to some parts, and it is assigning the first part to this one, to the first variable, the second part to the second variable, the third part to the third variable. And by default, it is an empty space or a tab or a new line. It is used as a separator. But we are modifying the separator temporarily, so just for this time. And we are using this column as a separator. So in this case, I don't think it is. All this will go to the first variable, and the other variables will be empty. In this case, this will be used as a separator, and this will be stored to variable 3. So I think this should be the correct answer. And the other cases are not. Again, all of this will be assigned to variable 1 because it is not using spaces as a separator. It is using this one as separator, and so this will be the first chunk of the input, and this will be empty. This will be empty. Again, the same thing here. This will be assigned to the first variable, and this will be empty, and this will be empty. The same thing here. Everything that we type as input will be whatever it is will go to this one. So the correct answer should be this one. So this is the correct answer, and we can actually test it with just let's use this one as a test, and this one, just these two. So let me type this command. Now it is asking for some input. Let me copy this input here. Press enter. Now echo var1. This is the first variable. The second variable is empty, and the third variable is also empty. Now, if we try it with this input, the first variable is 1, the second variable is 2, and the third variable is 3. Because we are using this column as a separator. Let's move to the next question. The script foo is called like this: foo1, 2, 3. So we are passing it 3 arguments. Which of these lines inside the foo script will pass to the cat command 3 arguments? So this is a line inside this script. Now, which of these lines is going to pass 3 arguments to the command cat? this is the inside the script. This special variable is the number of arguments. So it is 3. So it is not going to pass 3 arguments to the command cat. It is just going to pass the number 3 to the command cat. This one, $* inside the script, again, is a special variable, and it is going to be replaced by the shell by all the arguments. But actually, because we are surrounding it with double quotes, the command cat will get just a single argument that contains this string. So again, the command cat is going to get just one argument in this case. Again, in this case, it is going to get one argument. The command cat is going to get one argument because of this double quotes. So this will be replaced with the first argument. This will be replaced with the second argument. This will be replaced with the third argument that are passed to the script. But the command cat itself is getting just one argument because we are surrounding them with double quotes. So it is getting just one argument. And again, no matter what value has this special variable, it may have the value of 0 or 1. But because of the double quotes, the command cat is getting just one argument. Only this one is passing 3 arguments to the command cat. So again, this represents all the arguments that are passed to the script, similar to this one, but this is like an array. This is like a string. So it doesn't matter that we are surrounding it with double quotes. Again, still, this command will get 3 arguments. So I think the correct answer is this one. What will print this command? Echo new variable. What do you think, Andre? We just did it in. Okay. Let's test it. It is printing this variable. Why? Because the variable new, this is the name of the variable actually, but this is an undefined variable. So it is empty. It is not defined, and this kind of operator makes the so in case that the variable is empty, this value is used instead. So it is like if it is empty, if the variable is empty, then echo variable, else echo. So it is like this, because this is empty, this value is passed instead. So the correct answer is this one, variable. So this command will print variable. Which of these commands prints false? Select one. So does this one print false? This 0 inside an arithmetic.
I think it's maybe the D.
This one.
If false true, then echo true.
Mm-hmm.
Else echo false.
Okay, let's check this one. If false true, the command if is taking these two commands as a test. The first one is false. The second one is successful, but only the last command matters. When there are several commands, only the last one matters. So this test will actually succeed. So all of these commands will be considered as successful. And because they are successful, then this echo, this part, the part after then will be executed. So this will print true, not false. So this is not the correct answer. So we can check it actually. So it is printing true actually. It is not printing false. Okay, let's check this one. Can this print false? So we have this.
No, I don't think that.
Okay, let's reason about it. So we have these two. We have these two commands connected by this AND operator. The first command is true, and this command is also successful. So both of them are successful. Both of them are successful. So the whole expression is successful. And now, because the left side of this OR is successful, it will skip this one. It is not going to execute this command. So just this echo true will be executed. This one will not be executed. So let's check it. So again, this is executing this one, but not this one. Let us have a look at this one. Now, inside this one means true or false. This one. This number one inside arithmetic operator expression parenthesis means true. So this means true, and this is successful. Because this is successful, this will be executed as well, but this is printing true, actually. It is not printing false. So it will print again true. So this is true. Because this is true, and we have the AND operator, this command will be executed as well, but it is actually printing true, not printing false. So let's have a look at this one. This 0 means false because it is inside an arithmetic expression. It is an arithmetic expression. It means false. So this expression is fails. It is not successful. This expression fails. Because it fails, this command is going to be executed. But executing this command is going to print true anyway. It is not going to print false. So let's try it. It is printing true. And it remains that this one should be the correct answer, but let us check it. So we have true and false. We have two commands, but the last command matters, and the last command is failure. So all of these commands are considered to fail. The last command fails, all of them fail. So because these commands fail, then this will not be executed, but this one after else will be executed. So it is going to print false. So let us check it. Okay, this prints false indeed. So this is the correct answer. the next question. The script bar has a loop that starts with for I in, and then these are all the arguments. And we call this script like this, bar and some arguments. How many times are executed the commands inside the loop? The commands inside the loop are executed as many times as arguments as there are arguments. So this $@ sign surrounded by double quotes actually represents all the arguments of the script. So the for loop will be executed as many times as there are arguments. How many? What are the arguments? These are the arguments. But how many arguments are here? So this is the first argument, and because of the single quote, this is the second argument, and this is the third one, the fourth, and then this is the fifth argument. Because of the double quotes, this is one argument, and this is the sixth argument. So there are 6 arguments. The for loop will be executed 6 times. So I think this should be the correct answer. And let us actually test this. So let me write a script. So we have this for loop inside the script. Do, done. It doesn't matter. So let's make it executable, change mod plus X. And now we are going to call this script. Actually, the name of the script is bar. So let's make the name of the script bar. So let's call it bar and with these arguments. And it is executed 1, 2, 3, 4, 5, 6. And actually, we can improve this. Instead of just echo hi, we can echo the variable I. So these are the arguments A, and then this because of the single quotes. This is one argument, and then the next argument is this one. The next argument is this one, and this is one argument because of the double quotes. And the last argument is this. So there are 6 arguments, and the body of the for loop is repeated 6 times. So this is the correct answer, 6. How many arguments will be passed to the command echo if we call it like this? Echo, it's lots, isn't it? I won't be guessing. So what do you think? How many arguments are passed to this command?
I think 3.
Why do you think 3? Actually, we can test it with the command that we wrote, because it will display the arguments that we just wrote. It will display the arguments that are passed to it. So one, two, three, four, five. There are 5 arguments. Why? Because this is one argument, because there are no empty spaces, because arguments are separated from each other by empty spaces. And all of this is a single argument, because there are no empty spaces to split it. This is the first argument. And this is the second argument, the content of this string, without including the double quotes. And then the third argument is now this is tricky. This is a little bit difficult, because of this quote, it is considering this as one unsplittable string. So this cannot be splitted because of the quotes. But these are also concatenated. This is also concatenated with this one, and also this T is concatenated. So all of this is the third argument. And then this is easy, the fourth argument and the fifth argument. So there are 1, 2, 3, 4, 5 arguments. So it is a bit difficult, actually. Anyway. So what is the value of foo bar after this loop is finished? So we have a loop for, and then the variable foo bar in, and then this one. And there are these options, 0, 1, undefined, 5, 6. What do you think? So this variable foo bar takes one by one these values. First, it takes the value 5, and then it takes the value 5, and then it takes the value of this one, which is actually the number of arguments. It may be 0, for example. It doesn't matter. It has some value, and then it takes this value. This is the execution exit code, the exit code of the last command that is executed. It may be 0, 0, or 1, or 2, or something. It doesn't matter, but it takes this value. And then next, it will take the value 6, and then it will take the value 1. This is the last value that it is going to take. So after this is executed, I think it will be this one. So it is going to have the value 1. It is one chance that it is undefined, but most probably I think it should get the value 1. So let us test it, actually. So let us build a simple script that does this. So copy. So the script contains this loop. And let's do an echo. To see what is the value of this variable after the loop is finished. Not here. So we want to know the value of this variable after the loop is finished. So we are just printing it. So let's make it executable. So actually, it has the value 1. Why the value 1? Because this is the last value in the list. It is taking the values in the list one by one, and the last value that it takes is this one. So after the loop is executed, it still has this value. So this is the correct answer. Okay, that is the correct answer. And we are done with the quiz 4. We will do quiz 5 next time, but let's look at some of the assignments, some programming assignments. So we have the second assignment. We will start with the second assignment. It is requiring to write 2 scripts, but let's look at the second one first, because I think it is simple. Write a script that calculates the Fibonacci numbers. You can use as help this algorithm. Use the iterative algorithm, not the recursive one. Tab. So Fibonacci numbers are calculated like this. We start with 2 numbers, and then the third one is equal to the sum of 2 previous numbers. Then add these 2 up is the next number. Adding these 2 numbers is the next number, and so on. In general, Fn is equal to Fn minus 1 plus Fn minus 2. So this is an algorithm for calculating Fibonacci numbers in pseudocode. This is a function. It says procedure, but it is a function. Actually, the name of the function is Fibonacci, and it is taking as argument this n, which is, for example, if n is 5, we want to know what is the 5th Fibonacci number. Fibonacci number in the 5th place. And it is using these variables, f0, f1, fib, and loop. Initially, we set fib0 to 0, fib1 to 1, and then it is doing a for loop. But let us actually write a script. Let's try to write a script that solves the Fibonacci, finds the Fibonacci numbers. So let's say that the first argument is the which Fibonacci number we want to find. For example, we are going to use this script like this. So we are going to pass an argument to the script, which is the place of the Fibonacci number. So this is the Fibonacci number in the 3rd place. We want to know what is the Fibonacci number in the 5th place, what is the Fibonacci number in the 7th place. So the argument is on $1, and we are storing it in this variable n. So the variable n is the the term of the sequence that we want to calculate or to find. Now, if this is undefined, let us check that we are getting actually an argument. If no argument is given, then the script should print an error. So if it is 0 or undefined, then we should show the usage. So how this script can be used. And this is an error message, so we are sending it to the standard error. And exit the script with an error exit code. So we make sure that this is not empty. This $n is not empty. This variable n is not empty. It has a number in it. And now, if n is equal to 0, then the first Fibonacci number is actually 0. So let's check this case. So we check whether n is equal to 0. If it is equal to 0, then we echo 0, because the Fibonacci number in the first place, which starts with index 0, is actually 0. And then we exit the script so that the execution does not continue. And if n is equal to 1, then the second Fibonacci number is 1. And then again, we exit. So we assume that n is 2 or greater. So n is 2 or greater. Now, on this variable f0, we are storing the first Fibonacci number, and f1, we are storing the second Fibonacci number. So the first Fibonacci number is 0, and the second Fibonacci number is 1. Now, let's write a for loop which is repeated n minus 2 times. So we start for I equal to 1, I less than n, and then increment I by 1, I plus plus. It should be double parentheses, do, and then close the for loop, done. Now we calculate the next Fibonacci number in the variable fib, and it is actually the sum of the previous Fibonacci numbers, and the previous Fibonacci numbers are f0 and f1, f0 plus f1. So after calculating the next Fibonacci number, we shift the two numbers. So f0 now should take the value of f1. So it takes the value of the first Fibonacci number, actually. And f1 takes the value of the fib, which is the third one. And then this cycle is repeated n minus 2 times. Why n minus 2? Because we start from 1 and we go up to n minus 1. N minus 1. So it is less than n. I is less than n, which means it is less than or equal to n minus 1. And after repeating this n minus 2 times, at the variable fib, we are going to have the nth Fibonacci term in the sequence. So we just display it, and we are done. Or is this correct? So let's check it. Change mod plus x, make it executable. Without argument, it is just showing how the script should be used. This is $0, which is the name of the script itself, and then we should pass a number as an argument. So the Fibonacci number in the first place is 0, in the second place is 1, and let's continue. In the second place, it is still 1. Still 1, yes, because 0 plus 1 is 1. In the third place, it is 2, because 1 plus 1 is 2. In the fourth place, it is 3. 1 plus 2 is 3. In the fifth place, it is 5. 2 plus 3 is 5. In the next one is 8, because 3 plus 5 is 8. The next one is 13, because 5 plus 8 is 13. And the next one is 21, because 8 plus 13 is 21. So it is working as expected. So this is the correct solution. So this script works. Now let's have a look at the other problem. Write a script that solves the problem of towers of Hanoi. So let's look at the towers of Hanoi. The towers of Hanoi, we have n disks in one tower, and then we want to move them to another tower using a third one as a helper. And at each moment, not a small disk can be placed over a large disk, but a large disk cannot be placed on a smaller one. So this is a condition that we cannot place a disk over a smaller disk. So a small disk over a larger one is okay, but it is not possible to place. It is not allowed to place a large disk over a small one. So this is an algorithm for solving this problem, and it is actually a recursive algorithm. So this is the start of the algorithm, and this is the stop. We are declaring a function here. It is called procedure, but it is actually a function, Hanoi, and this function is solving it. This is the number of disks. This is the source tower, the destination tower, and an auxiliary tower. Okay, maybe it is better to explain it by writing the script. So let's say that we want to know how many disks are there. So let's use a read command to get the number of disks. And we are going to read this to the variable disks. So we are asking, we are using this one as a prompt, and we are storing the answer into this variable. So let's make the script executable. And let's try Hanoi. Towers of Hanoi, how many disks? Let's say 5. It is just displaying the number of disks for the time being, but we are going to improve the script. And to solve, to solve the problem, we are going to use a function. We will write a function. Let's call it solve Hanoi. And this function actually is taking 4 arguments. So the first argument is the number of disks. The second argument is the name of the first tower, or the source tower. And the third argument is the name of the destination tower, where they should go. And the last argument is the name of the auxiliary tower. Or we can shorten this name. Let's say source, destination, or dest. And aux. And let's say this is this. So this function is taking these 4 arguments. So let's store these arguments into variables. So local disks. This is the first argument, and then this is the second argument, and then this is the third argument, and auxiliary is the fourth argument. Now, if the number of disks is 0, so how many moves we have to do to solve the problem? No moves at all, because there are no disks. So if number of disks is 0, then nothing needs to be done. But we can this one. But if the number of disks is greater than 0, then we have to do some steps. So only if the number of disks is greater than 0, we have to do some steps, something. And then, oops. And I'm closing the if. So how do we solve? If we have n disks, First of all, we move the first n-1 disks that are on the top. So we leave only the largest disk on the bottom, and then we move n-1 disks from the source tower to the auxiliary tower, using the destination tower as auxiliary. So I'm going to call this function recursively. So inside the definition of the function, we are calling the function itself. This is called a recursive function in programming. So solve Hanoi with n-1 disk for the So we will solve this problem for n-1 disk. This is n disk, this is n-1 disk. So we are moving the disks that are on the top. They are on the source. So we are moving them from the tower source to the tower auxiliary, using the destination as a helper, actually. And then after we move this n-1 disks, we move the last disk. And it will move from the source tower to the destination tower, which is now empty. And then after doing this, we are going to move this n-1 disk from the auxiliary to the destination using source as a helper. So again, solve Hanoi for disks -1. Now they are on this tower, so we are going to move them from auxiliary. We want to move them to the destination tower with the help of the source tower, which is free right now, has no disk on it, and this should solve the problem. But now we have just defined this function. We have not called it yet. So let's call it after reading the number of disks. Let's call this function to solve the problem. And we are giving it the number of disks. And let's call it this one source, and the destination, we call it destination, and auxiliary. But we can call it we can call the towers anything. For example, we can call it A, or A and B and C. So these are just names. They can be anything. So we want to move this many disks, for example, 5 or 7 or 8, from the tower named A to the tower named B with the help of the tower C, named C. And let's try it. Towers of Hanoi. How many disks? Let's say 1 disk. If there is only one disk, we just move it from A to B, and the job is done. Towers of Hanoi. How many disks? 2 disks. If there are 2 disks, then we move the top disk from A to the C tower, and then we move the second disk from A to B, and then we move the disk that is on C to the B, and we are done. So if there are 2 disks, move the first one to C, move the second one to B, and then from C to B. How many disks? Let's say there are 3 disks. And then it is showing the steps. Move the top disk. Move the top disk from A to B. Then move the top disk from A to C. The disk that is on top of A, move it to C, and then move the disk that is on top of B to C, and so on. So let's try it again with 4 disks. So it is increasing quickly. Let's try with 5. It's becoming even longer. Let's try it with 8. Let's modify the script so that it counts how many moves, how many steps it needs to move all the disks. So, first of all, before starting to solve it, we declare a variable, number of moves, and we initialize it to 0. And then we call this function. And then each time that we make a move is made here, we just increase or increment the number of moves. So how do we do it? We can increment it like this. Number of moves plus plus. So this is one way of incrementing it. And last, after we print the solution, we can also print the number of moves. Echo. It took number moves to solve Towers of Hanoi for disks. So let's try this. Oops. How many disks? 3. For 3 disks, we need to make 7 moves. 1, 2, 3, 4, 5, 6, 7. For 4 disks, 15 moves. For 5 disks, 31 moves. For 6 disks, 63 moves. In general, it is number of disks 2 to the power of number of disks minus 1. So if it is 5, for example, it is 2 to the power of 2 to the 5th power minus 1. 2 to power 5 is 32. Minus 1, 31. If it is 6, it is 2 to the power of 6, which is 64. Minus 1, 63. Okay, this was also the second problem, and next week we will continue after doing the other lessons with more solving a couple of more assignments or examples.